Good morning, students. Let us continue with the problems of Chapter 9, Force and Laws of Motion. In today's session, we will do the last problem, A4, from the additional exercise given on page number 130 of your textbook. A4. A motor car of mass 1200 kg is moving along a straight line with a uniform velocity of 90 km per hour. Its velocity is slowed down to 18 km per hour in 4 seconds by an unbalanced external force. Calculate the acceleration and change in momentum. Also, calculate the magnitude of the force required. First of all, let us understand the question. What is given here? Here there is a motor car of mass 1200 kgs and it is moving in a straight line with a uniform velocity of 90 km per hour. But after some time it is slowed down to 18 km per hour in time 4 seconds, and this is done by an unbalanced external force. Here we are asked to calculate acceleration, change in momentum, and the magnitude of the force required. First of all, we will calculate the acceleration. Given here are the initial velocity u equal to 90 km per hour. This 90 km we will be converting into meters per second. For this, we take 1 km equal to 1000 meters and 1 hour equals 60 minutes and 1 minute equals 60 seconds. That implies 1 hour equal to 60 into 60 seconds. Substituting these values, we get the initial velocity as 25 meters per second. We do the same thing with final velocity. Final velocity V is given as 18 kilometers per hour. This is when the vehicle is slowed down. If you notice here, initial velocity u is much bigger than the final velocity. So this decrease explains the fact that the vehicle has slowed down drastically due to the application of external force. This 18 kilometers per hour will be converted into meters per second in the same manner as we did for initial velocity. Here again we take 1 kilometer equal to 1000 meters and 1 hour as 60 into 60 seconds. Using this we get final velocity V as 5 meters per second. Now to find the acceleration, and the time given is 4 seconds. Using the values of t, v and u, we can find A using the formula V equal to U plus AT. Substituting, we get 5 equal to 25 plus A into 4. This implies 4A equal to 5 minus 25, 4A equal to minus 20, A equal to minus 20 by 4, and A equal to minus 5 meter per second square. Students, if you notice, this minus sign indicates the negative acceleration or retardation. This is because the vehicle had slowed down from a high velocity to a lower velocity. That means from a higher acceleration to a smaller one. That is why the negative sign is shown here. Next, we calculate the change in momentum. Now we know the formula for momentum, product of mass into velocity. But here we are asked to find the change in momentum. That means the difference between final momentum and the initial momentum. So to find the final momentum, it's the product of mass into final velocity, V. For finding initial momentum, it is the product of the same mass m into initial velocity u. Substituting these values, we get change in momentum equals 1200 into 5 minus 1200 into 25. That equals 6,000 minus 30,000. That equals minus 24,000 kg meter per second. Thus, the change in momentum is 24,000 kg meter per second. The third part is calculation of magnitude of force. We know the formula for force, that is mass into acceleration. F equal to m into a. Here we are finding the force that was applied to slow down the vehicle. What was that external unbalanced force? So F equal to the mass 1200 into acceleration, that is minus 5. So we get the product as minus 6,000 newtons. So the magnitude of force required is 6,000 newtons here. And the negative sign shows that the force is an opposing force. It opposes the motion of the vehicle. That's all for today, students. With this, we come to the end of chapter 9, Force and Laws of Motion. Thank you.